Hi my dear students, in the previous videos we discussed the theorems, so many theorems I discussed. So among that, I discussed the very important theorem is my dear students, A into adjoint of A is equals to or adjoint of A into A is equals to determinant of A into I, where I is the identity matrix. This result I proved in the earlier videos. Clear. And also my dear students, I discussed that here it is A is invertible. So A is invertible if A is non-singular. Clear. So A is invertible if A is non-singular. While proving if and only if A is non-singular. So while proving that, I got the one result. What is that? A inverse is equals to 1 divided by determinant of A into adjoint of A. Clear. Where here this is the formula for the next we are going to discuss to find the inverse of the any given matrix. Clear. So this is the formula I am going to use in future while solving the questions to find the inverse. Clear. So if I wanted to find the inverse means I should find this one. What is the formula? At 1 divided by determinant of A into adjoint of A. And here you can observe here it is. Here A must be non-singular. Why A must be non-singular? So I already in the last class I told you. What is that? If A is singular means what happens? A is singular means determinant of A is equals to 0. But here it is I should require A is determinant of A should not be equals to 0. For that reason A must be non-singular. It means if A is invertible, if and only if here it is A is non-singular. That result I proved. Clear. So here determinant of A should not be equals to 0. If determinant of A is equals to 0, then what happens? It's not possible to find out the A inverse, because here if you put the value determinant of A is equals to 0 means what happens? 1 divided by 0 is not defined. So for that reason we should always keep in our mind that determinant of A should not be equals to 0. Determinant of A should not be equals to 0. If determinant of A is not equals to 0 means what it indicates? It indicates that A is non-singular. Clear. So this we discussed in the earlier classes. These all results we discussed. And now my dear students, in today's class I am going to discuss the question based on this. So what is that? The question here I wrote here. Here, if A is the one matrix of the order 3 cross 3 given to you, then verify that A into adjoint of A is equals to determinant of A into I. We should verify that whether A into adjoint of A, if I multiply means whether I am getting the value as determinant of A into I. So that I should verify. And then they also ask you to find A inverse. Clear. So this is the result they ask you to verify, as well as this A inverse we should find out. Clear. So to find out this, what I will do my distance, first I will calculate the adjoint of A, and next I will calculate the here it is determinant of A. So whenever you are calculating the A inverse, please keep in your mind what is that? Determinant of A should not be equals to 0. So that you should check whether the determinant of A is equals to 0 or not equals to 0. That you should check. If determinant of A is not equals to 0, here then you can solve further. But if determinant of A is equals to 0, then it's not possible to find out. Clear? Because A inverse does not exist. If determinant of A is equals to 0, then it's not, the A inverse does not exist. Clear? So for that reason, first I will find out my distance here, the determinant of A. So how to find the determinant of A here? Determinant of A is equals to, here it is. To find out the determinant of A, let us first consider, let A is equals to, here it is 1, 3, 3, 1, 4, 3, 1, 3, 4. So this is the A matrix we have. Now I should find out the A, here it is, I should find out the determinant of A. While solving the determinant of A, already I told to you. So what is that? First we should change the sign. This is plus minus plus minus plus minus plus minus plus. So change the sign. And now here expanding along row 1. So we should expand along the row 1 here this. So here if we expand along row 1 means we should consider the first row. So therefore determinant of A is equals to here plus 1 into, leave this row and this column. So what is the, you should take the remaining elements determinant. So 4 4 is a 16, minus 3 3 is a 9. Next, minus of 3 into, leave this row and this column. 4 into 1 is 4, minus 1 into 3 is 3. And next, plus 3. So plus 3 into, leave this row and this column. So 3 into 1 is 3, minus 4 into 1 is minus 4. And this will gives you, so determinant of A is equals to 1 into 16 minus 7. How much it is? 16 minus 7, 16 minus 9 is, here it is 7. Next, minus 3 into 4 minus 3 is 1, plus 3 into 3 minus 4 is minus 1. So further, if you simplify means, you will get, here it is, this is 7 into 1 is 7, plus minus minus 3, plus minus 3. So this will gives you 7 minus 3 is minus 6. So therefore, here it is, determinant of A is equals to 7 minus 6 is equals to 1, and which is not equals to 0. So since determinant of A is not equals to 0, it means here it is A is non-singular. So if A is non-singular, then you can find out the A inverse. Clear? So now my students, next I should find out, here it is adjoint of A. First I should verify that A into adjoint of A. So for that reason, and also I require the determinant of A. So first I calculated the determinant of A, and next I will calculate the adjoint of A. So we know that. So how to find out the adjoint of A? Adjoint of A is, we know the formula. What is that? Adjoint of A is equals to, here it is A11, A12, A13. Next, A21, A22, A23, A31, A32, A33, whole transpose. Clear? So adjoint of A is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. So A11 means what it indicates? A11 means cofactor of the element A11. So cofactor of the element A12, cofactor of the element A13. We will denote like this, capital A. Clear? So now we should take the transpose of this. So that will gives you the adjoint of A, that will gives you. So either you can write like this, or transpose of A11, A12, A13, A21, A22, A23, and next A31, A32, A33. So transpose of this you can write, or you can take the whole bracket, on the bracket you can write transpose. So this is a notation for the transpose of a matrix. Clear? Either you can write like this, or you can write trans of this. Both are meaning same, only the notation is different. But now my dear students, so in the next onwards I use this symbol, transpose of, either you can write like this, transpose of this matrix or this matrix whole to the power t. Both are same, but usually we will denote this notation. And now my additions. First we should find out the A11, and that I discussed already. So how to find out the A11? So A11 means what? A11 means that is nothing but, here it is cofactor of the element A11. Clear? So here I should, capital A11 means what? Capital A11 means, here it is capital A11 means it is nothing but cofactor of the element A11. So what is the cofactor of the element A11? How to find out the cofactor of the element A11 means, that is minus 1 whole to the power, whatever subscript you have that you should write, 1 plus 1 into minor of 1 1, m11. So and this is equals to, here it is minus 1 whole to the power 1 plus 1. So minus 1 whole to the power 1 plus 1 means minus 1 whole square. So minus 1 whole square is nothing but plus 1. So I will write, here it is plus, here it is plus 1. 1 I am not writing because it is understood 1 into anything is 1. So simply I write the sign, that is positive. M11. What is mean by M11? M11 means it is minor of the element A11. So minor of the element A11, how to find out? To find out the minor of the any element, that row and column you should delete. If I wanted A11 element, this is our A11 element. So leave this row and this column. After deleting this row and this column, you should take the determinant of the remaining values. So that value is the, here it is, minor of A11. So therefore, I will write here this M11 means what? M11 means A11 element minor. So if I wanted to find the A11 minor means leave this row and this column. Whose elements minor you require, that elements row and column you should delete. Clear? So if you delete this row and this column means what is remaining elements? That elements are 4, 3, 3, 4. Solve this one. So that will gives you the, here it is, cofactor of A11, that is capital A11. And similarly my students, A12. So how to find out the A12? That is, here it is cofactor of the element A12. So that is minus 1 whole to the power 1 plus 2 M12. Clear? So this will gives you minus 1 whole to the power 1 plus 2 means it's minus 1 whole to the power 3 means odd. So odd means it is minus 1. So just I write minus. And now M12. M12 means this element minor. So if I wanted to find this element minor means delete this row and this column. So remaining elements, what are remaining? 1, 3, 1, 4. 1, 3, 1, 4. Clear? So like this you should calculate. And next my students, A13 is equals to cofactor of A13 is equals to minus 1 whole to the power 1 plus 3. So 1 plus 3 into minor of 1 3. So minus 1 whole to the power 1 plus 3 means it's minus 1 whole to the power 4. So minus 1 whole to the power even number means that is positive. Clear? And now minor of M13, A13. So leave this row and this column. So 1 4 1 3. 1 4 1 3. Like this you should calculate. So next here it is A21. So it is cofactor of A21. So here it is minus 1 whole to the power 2 plus 1 into M21. So minus 1 whole to the power 2 plus 1 means 2 minus 1 whole to the power 3. 3 means odd. So odd means again you will get minus, negative you will get. So minor, then determinant of M21 means this element minor I required. So therefore delete this row and this column. So what are remaining? 3 3 3 4. 3 3 3 4 determinant you required. And next M22 is equals to cofactor of A22. So here it is minus 1 whole to the power 2 plus 2 into M22. So minus 1 whole to the power 2 plus 2 means it's positive. So positive. So M22 means this element. Delete this row and this column. 1 3 1 4. 1 3 1 4. Like this you should write. And next M23 is equals to, here it is. Again here it is cofactor of here it is cofactor of A23. So cofactor of A23 is equals to, here it is minus 1 whole to the power 2 plus 3 into M23. So this is equals to minus 1 whole to the power 5. Minus 1 whole to the power 5 means it's negative. Clear? Already I told you minus 1 whole to the power. Already I told you minus 1 whole to the power even means, even number means that will give you positive. Minus 1 whole to the power odd means that will give you minus 1. Clear? So that I am using here this. And next M23. M23 means second row, third column. 1 3 1 3. 1 3 1 3. Next my students, this is A31. So capital A31 is equals to cofactor of A31. So minus 1 whole to the power this 31. Whatever subscript A subscript you have, that number you should raise. You should take the sum of those numbers 3 plus 1. So it is M31. So minus 1 whole to the power 4 means it's positive. And M31 means this row, the minor of this element I required. Delete this row and this column. So 3 3 4 3. 3 3 4 3. And next A32 is equals to, here it is A32 is equals to cofactor of a32 is equals to minus 1 3 plus 2 into cofactor of minus m32. So minus 1 whole to the power 3 plus 2 is 5. Again it's minus. So therefore m32 means leave this row and this column. 1 3 1 3 1 3 1 3 1 3. So this row and this column 1 3 1 3. And next my students a33. So cofactor of, here it is, a33 is equals to minus 1 whole to the power 3 plus 3 and minor of m33. So this is minus 1 whole to the power 3 plus 3 is 6. 6 is even number. So here it is positive. And next m33 means leave this row and this column. 1 3 1 4 1 3 1 4. So like this you can calculate. So this is all about the cofactors. Here it is a11 a12 a13 a11 a12 a13 a21 a22 a23 a31 a32 a33. So like this you should solve. So my dear students, please remember here, this already once I solved the same question while discussing the adjoint of A. In that case I discussed the same question for finding the adjoint of A. Clear? So now what I will do, my dear students, now every time like this we cannot write. Am I clear? So every time writing like this it's not easy. It will take your time. So for that reason, what I do, my dear students, you can observe here the signs. You can observe here it is to take the sign. What I will do here is, see here it is, for the element a11 it's plus, for the element a12 minus, a13 plus, a21 minus. So it means this is all about the first row, and a21 a22 a23 means this is all about the second row, and this is all about the third row. So every time minus 1 whole to the power 1 plus 1 minus 1 whole to the power 1 plus 2, like this writing it will take your time. So for that reason what I will do, my students, for the first row its sign will be fixed. I am taking here this, for the element, first element here it is plus minus plus, like this I will take, and minus plus minus plus minus plus, like this I will take. So that's why, my dear students, while solving the determinants only I use here this. We are changing the sign to be like this, plus minus plus. You can observe here this plus minus plus. First row plus minus plus. Second row, my dear students, you can observe here it is minus plus minus, minus plus minus. And for the third row plus minus plus, plus minus plus. So this is fixed for all the cases. So while taking the sign, no need to write like this. So directly you should skip. You can skip this step and directly you can write this. Plus of minor of this 4m11. So how to write here it is, directly a11 is equals to, I will write positive, because here it is we are using sign like this, plus minus plus. So plus of delete this row and this column. So you should take the remaining elements determinants 4 3 3 4 4 3 3 4, like that. And next second element minus of leave this row and this column. So 1 3 1 4 1 3 1 4, like this. And for this element here, this cofactor of I, if I require cofactor of this element means positive, we should take positive into leave this row and this column, 1 4 1 3 1 4 1 3, like this we should calculate. And further, my dear students, we can solve this by using determinant. So like this we can write. So every time I am not going to write all this directly. What I will do, adjoint of A is equals to directly this box only I will write. It means I will skip all this, directly I will write this. Clear? How can I write means, I can write here this, that is here I just, here is what I will do, I will just erase this part. Clear? So please pause the video up here to note it down. I will give you some time. So my dear students, instead of writing all this, what I will do, what I told, so I will erase. For that reason, first I will erase this one. So here it is, I will write all those A11 A12 values here, adjoint of in the next problems, in your annual examinations, what you will do, you will not write all these things directly. How to write means, here it is, adjoint of A is equals to, here you can write, here it is like this. What is that? A11. So what is A11? To write the A11 directly, I write this step. So how to write? Here it is plus, already we know, plus of, here it is determinant of 4 3 3 4 I have. So this is A11 element. So instead of writing all this directly, I will write this step. So how to write this step means, first we should take the signs like this, plus minus plus, minus plus minus, plus minus plus. So plus of, leave this row and this column, they take the determinant of remaining elements 4 3 3 4 like this. And next minus of, and again it is leave this row and this column, so remaining elements 1 3 1 4. And next my distance, plus minus, here it is plus, and next here it is this row and this column I should leave, this row and this column. So what is remaining? 1 4 1 3 1 4 1 3. We should take the determinant value of this. And next my distance, minus plus minus plus minus of this element, so leave this row and this column, so 3 3 3 4 3 3 3 4 minus, and next here this plus, this leave this row, this here in this position I am writing, this position element here I am writing, so I require the cofactor of this. So cofactor of this means plus of determinant of, leave this row and this column, 1 3 1 4 1 3 1 4. And next plus minus plus determinant of, leave this row and this column, 1 3 1 3 1 3 1 3. Clear? And next here it is again, then plus of, plus minus plus, minus plus minus minus plus, here it's minus, I'm sorry, I should write it as minus, yes, plus minus plus, minus plus minus, and next again here it is plus, leave this row and this column, so 3 3 4 3 3 3 4 3. And next minus of, leave this row and this column, 1 3 1 3 1 3 1 3. Next here it is plus of determinant of, leave this row and this column, 1 3 1 4 1 3 1 4. So this is your adjoint of A, whole transpose. So instead of writing all this directly, I wrote this step only. Whether I wrote correct or not, just I am verifying to you. This all I am writing everything here because to verify. So instead of writing all this directly, I can, how should I write means, here it is, I told you. So after writing this, whether you are getting the same value or not, just I will show you, verifying here this. So plus 4 3 3 4, plus 4 3 4 3 4. Next minus of 1 3 1 4, plus of 1 4 1 3. Next minus of, here it is 3 3 3 4, A 2 element, here it is 1 3 1 4. Next minus of 1 3 1 3, and next here it is plus of 3 3 4 3, minus of 1 3 1 3, plus 1 3 1 4. So instead of writing all this directly, you have this result. I mean, so in short you can write like this. So now you can easily calculate the determinant, and that will give you the adjoint of A you will get. Clear? So that if you are confused with this directly writing in this step, means if you are confused means, you can write like this and then you can further you can simplify. But here it is, instead of writing all this directly, your adjoint of A is equals to, like this you can write. Clear? I hope you understood. But next onwards, while solving the questions, I am directly to find the adjoint of A, what I will do, I will write this. I am not using this cofactor of everything, every element and minor. This all I am not going to write. Simply I write this step. Clear? I hope you understood. Still, if you have any doubts, you can comment me. So clear? So this is all about the adjoint of A. So in short, or how to find out how to write adjoint of A, I told you, but not at your question completed. It's just I calculated, here it is adjoint of A. Clear? So I erase this part. So just I verified, here it is. Instead of writing all this directly, you can write like this. You can skip all this writing. Clear? So therefore I wrote here this. But actually next onwards, to find the adjoint of A, this I will write like this. I am going to write. Clear? So I will erase this one so that I can have space. So next, my students, what is your main question? Main question is verify that A into adjoint of A. So adjoint of A, here it is. Further I should simplify here. So simplify this one. So if you simplify, this is nothing but determinant symbol. So already we discussed how to find out the determinant of the order if the matrix is of the order 2 cross 2. So how to find out the determinant for this? Here it is 2 cross 2. To find out this 2 cross 2, multiply this element into this element, minus of this element into this element. Clear? So therefore here I am going to write, here it is, adjoint of A is equals to, so here adjoint of A is equals to, don't confuse, whatever I wrote here, it is wrote that all to verify you that I wrote. But next this directly in examinations, don't get confused. So what should we do in examinations? If they given to the question like this, means first you will find the determinant of A and then we will write our adjoint of A. So adjoint of A I am writing like this. So further simplify this. So here it is plus of, here it is plus means no need to write, leave this one, simply write the value. So 4 4 is a 16, 4 4 is a 16 minus 3 3 is a 9. So here it is 7. 4 4 is a this element into this element. 4 4 is 16 minus of 3 3 is a 9. So 16 minus 9 is 7. And next minus of, so minus of this element. So 4 1 is a 4 minus 3 1 is a 3. So 4 minus 3 is 1. And here it is plus of, so 3 1 is a 3 minus 4 1 is a 4. So 3 minus 4 is minus 1. Clear? And next, my students, here it is minus of 4 3 is a 12. 4 3 is a 12 minus 3 3 is a 9. 3 3 is a 9. 12 minus 9. 12 minus 9 is 3. And here it is minus 3. Next 4 ones are 4. 4 minus 3 is 1. Next 3 minus 3 is 0. Minus 0 is 0 itself. And next 3 3 is a 9. Here it is 3 3 is a 9 minus 4 3 is a 12. So here it is minus 3. And next here it is minus of, here it is minus of 3 1 is a 3 and 1 into 3 is 3. 3 minus 3 is 0. Minus 0 is, here it is 0. Clear? And next here it is 4 1 is a 4 minus 3. 4 minus 3 is 1. And we should take the whole transpose. Please remember, here it is in examinations, what you will do, you calculate all this and you will write directly this as a adjoint of A. But actually it's not adjoint of A. Adjoint of A is this whole transpose. So therefore we should take the transpose. So this will gives you, so this is transpose means we should take the transpose means what should we do? We should write the rows in terms of columns. That will gives you the transpose of this matrix. So here it is, this I can write here it is as 7 minus 1 minus 1. This row I am writing in rows, I am writing in terms of columns. So here it is minus 3 1 0 minus 3 0 1. So here it is, this is your adjoint of A. So next, what should we verify? Then verify that A into adjoint of A. Already you have A and adjoint of A also you just now calculated. So therefore A into adjoint of A. So consider, here it is, consider A into adjoint of A. So what is A? What is A into adjoint of A? So what is A here? It is A is 1 3 3 1 4 3 1 3 4. This is A. A, we should verify that A into adjoint of A. So this is A into adjoint of A, already I have. So 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So now multiply these two matrices. So how to multiply the two matrices? That already we know. So how to multiply that matrices, two matrices, my dear students? So the two matrices can be written here is row into first column. Clear? So therefore this will gives you here it is, here it is, I can write here it is, or else I'll write below only so that I can have more space. Clear? So row into column, so therefore this is equals to here I can write here it is rows into column. So first row, first column, 1 into 7 is 7, so 3 into minus 1 is minus 3, 3 into minus 1 is minus 3. First row, first column. Next, first row, second column. I think you know how to multiply the two matrices. So first row, first column, first row, second column. So 1 into minus 3 is minus 3, 3 plus 3 into 1 is 3, plus 3 into 0 is 0. Next, first row, third column. So therefore here it is 1 into 3 is minus 3, 3 plus 3 into 0 is 0. First row, third column, 1 into minus 3 is minus 3, 3 into 0 is 0, plus 3 into 1 is 3. So like this you can calculate. Next, second row, first column. So here it is 1 into 7 is 7 minus 4 minus 3. Next, first row, second row, second column, 1 into minus 3, 4 plus 4 plus 0. And next, second row, third column, 1 into minus 3, 4 into 0, 0, plus 3 ones are 3. Next, my dear students, third row, first column. So here it is 1 into 7 is 7 minus 3 minus 4. Next, third row, second column. So 1 into minus 3 is minus 3 plus 3 plus 4 into 0 is 0. Next, third row, third column. 1 into minus 3 is minus 3 plus 3 into 0 is 0 plus 4 into 1 is 4. Clear? So this is all about your A into adjoint of A. So simple multiplication is there. That how to multiply the two matrices, that already we discussed. So use that one. And this is equals to how much it is, my dear students? So minus 3 is minus 6. 7 minus 6 is 1. So plus 3 minus 3, yeah, got cancels 0. So 0 minus 3 plus 3 got cancels 0. And next is 7 minus 7, 0. So minus 1 plus 0 is leave this one. 4 minus 3 is plus 1. So plus 3 minus 3 is 0. And next to minus 3 minus 4 is minus 7 plus 7 is 0. Plus 3 minus 3 is 0. So 4 minus 3 is plus 1. So this is what your, here it is, identity matrix. Clear? So my dear students, please remember what they asked you. We should verify that A into adjoint of A is equals to determinant of A into I or not. We should check whether A into adjoint of A value is equals to determinant of A into I or not. That we should check. My dear students, this observe here it is. What is this all about? Here it is A into adjoint of A. What I got here it is A into adjoint of A is equal to, this is LHS and I end up with the RHS. What is that? 1 0 0 0 1 0 0 0 1. So this is your identity matrix. This can I write here it is 1 into 1 0 0 0 1 0 0 0 1. So 1 into this matrix, can I write here it is, this value is also same. But 1 means what is the value of 1? So is our determinant of A, determinant value A of A, determinant value is 1. So this 1 can I write it as determinant of A into 1 0 0 0 1 0 0 0 1, and this finally I can write here this determinant of A into this is nothing but identity matrix. So therefore A into adjoint of A. So what is the answer I got? The A into adjoint of A can be written as determinant of A into I. So this is what I should require to prove. Then here this. Clear? So A into adjoint of A is equals to determinant of A into I. A into adjoint of A is equals to determinant of A into I. So this I prove. And next, then verify that A into adjoint of A is equals to determinant of A into I. This part I completed. And next what they ask, also find A inverse. So next you should find out the A inverse. So now my dear students, now we should find out the A inverse. Now A inverse is equals to, so what is the formula A inverse? Already I discussed. The A inverse formula is 1 divided by determinant of A into adjoint of A. Clear? So A inverse value, A inverse formula is 1 divided by determinant of A into adjoint of A, and this is equals to, what is 1 divided by determinant of A value is, here it is 1 into, what is adjoint of A? Adjoint of A I have here it is, where it is adjoint of A is equals to this much. So here it is 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So this is your 1 divided by determinant of A value is 1. Here it is. And next adjoint of A is, this is the matrix. So 1 by 1 is 1. 1 into this much is again this matrix only 7. So 1 into anything is again we get the same value, whatever 1 to the 1, whatever you are multiplying, the same matrix you are getting. So therefore here it is 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So this is what you are required A inverse. So like this you should solve my questions. So this is very important concept I discussed here. This is what is that that concept? That concept is, instead of writing every element's cofactor directly, I am going to write this one. This is adjoint of A. Like this we should find out the adjoint of A, and even A inverse. How to find out the A inverse, that I discussed in this question. So please try to practice this question, and please remember already adjoint of A for this, for the same example I discussed. Clear? So now here it is. In this concept, the new concept I discussed is A inverse. Clear? So please try to practice this question. So based on these questions, we can solve some more examples in the next classes or next videos. Clear? I hope you understood. Still, if you have any doubts, you can comment me. I'll reply for that. Thank you.